we're going to use mathematical induction to prove AMGM inequality for n variables. And there are multiple ways for the induction. Here I'm going to share two methods with great algebra tricks. Just review that AM, arithmetic mean, it is average of n variables, and geometric mean is a product and then the nth root. It is a very useful inequality, and it has many applications in calculus, in optimization problems, and other mathematical problems. For the base case, that's n equal to 2 variables. That's quite straightforward. Okay, so based on the fact that any real number square is non-negative, and then you expand it out, and then you move this square root to the right hand side, divide by 2, that's exactly the AM and GM. Okay, so base case, straightforward. Now for the induction step, assume it is true for n equal k, and we would like to prove that is also true for n equal k plus 1. For n equal k, in this case, for some k greater or equal to 2, what it means is that we assume this is true, m greater or equal to gm. Now we want to show that for k plus 1 is also true. Okay, for easier notation, I'm going to use L and R to say left hand side and right hand side expression here. The L meaning the arithmetic mean for k plus 1 variables. R is for the geometric mean of n plus 1 variables. For the first method, let's look at the sum of n plus 1 variables. Okay, we're going to rewrite it by putting k minus 1 r, and of course you need to subtract that in order for this equality to hold. The reason we want to group this is such that we have two sets of k numbers. We can apply based on the induction assumption here. For the k variable, we have AMGM. So apply the AMGM for k variables for this two term in the parentheses. Notice that the sum here would be greater or equal to k times the geometric mean. All right. So here we're going to apply that for two group of k numbers. Let's go. All right. So recap. What we have is the AMGM inequality, and now you're going to apply the AMGM for two variables. For the first two term, a plus b greater or equal to 2 square root of ab. Let's do that. For this two term, you can put the product together. Okay, so take out k. This is nothing but 2k, right? Square root of kth root is going to be 2kth root. Remember, r is a geometric mean of k plus 1 variables. So which means you raise to k plus 1's power is going to be the product. So this is r2k and then 2kth root. So that's exactly 2kr minus the other term here. You're going to have k plus 1r. So what we have is that this one here, the sum, is going to be greater or equal to k plus 1r. Now if you divide k plus 1, you get exactly the L, which is arithmetic mean, and R, which is geometric mean, with this inequality. So we have shown that if this is true for n equal k, we have shown that it is also true for n equal k plus 1. So that completes the induction proof. Now for method 2, which is very similar, but we're going to work with L instead. Remember, what is L and R? L is the arithmetic mean, R is geometric mean. Now remember, in the first method, we started with this quantity and we use R, right? So this time, we're going to treat it a different way, right? So this is k plus 1 L, yeah? And what we do is, we're going to rewrite L in terms of k plus 1, k minus 1, and 1 over 2k, right? What is k plus 1 L? That's just the sum of this k plus 1 term, yeah? Now here, we're going to also group them, okay? What we group is, we're going to group k term here, and the rest is also k term, right? So we have k term and k term, and this value is k minus 1 term of L, right? So we're going to apply AMGM for k variables, just like what we did in method number 1. Okay, if we do that, you're going to say this is going to be k and geometric mean, k and geometric mean. You notice that you can cancel k, and you have two terms. Again, we use the same trick, which is apply AMGM for two numbers, a plus b is going to be greater or equal to 2 square root of ab, and 2 would cancel with this 2, so which means we're going to have this relation here. Now what is this? This is just the square root of 2k, right? So let's do that, 2k. And here, the product here is r, right? So let's rewrite. So what we have so far, we're going to raise to 2k's power, and then cancel L, right? On both sides, you're going to add k plus 1, and over this, right? This is exactly L, this is R. L greater or equal to R. So which means we have also shown that the inequality holds for n equal k plus 1. Okay? These two methods are similar in essence, but one works with R, one works with L. We introduced two methods here. Hope you enjoyed the video today. And there are many other proofs for this AMGM inequality. One famous one is Cauchy's what is called forward-backward induction, and that is also interesting. We are going to cover perhaps in another video on that method. In the meantime, please like, share, and subscribe to the channel.